Greetings and welcome to Kizana's FinTech channel, where I take you from zero to master in IT and DevOps. And in this video today, we're going to talk about Git, because I hear that there's a lot of people who actually don't understand the fundamentals of Git, and this video is hopefully going to help you out with that. I'm going to step you through some of the basic fundamentals in this video, and this is going to be a precursor to a future video that I'll create that's going to step through some more advanced concepts, because when it comes to release management, some of the branching and the merging strategies can get a little bit difficult, and if we're not all on the same page, it's just not going to work out. So in this video, I'm going to step you through the very basics, the very first introductory things, and this is going to lead to a more advanced setup. So with that said, we'll go ahead and get started. Oh no, the terminal, whatever shall we do? It's so dark. It's so mysterious. You're going to get really comfortable with this. This is my preferred interface when dealing with Git, because I know the command line the best, and also I know it's not going to do something funky behind my back. I've had some experiences with like Tortoise SVN, Tortoise Git, the stuff that's built into the VS Code IDE, and let me tell you, some of these things, some of these graphical user interface, these GUIs, are just a little iffy when it comes to some of the operations they do. If it works for you, that's great. Have fun with it. I'm going to teach you what you need to know as far as like the commands and stuff are concerned, because that's what's going to get the job done. Now, if you're on any Linux system, you can just man Git and you can read the manual. I mean, there's lots and lots and lots of stuff to read, and if you don't like that and you want a graphical web version of it, you can man Git in the Google search bar, and that will pull up the documentation. And well, this is very dry, very boring, very factual, has all the information you need. It's not the same thing as getting the experience, and so the best way to get experience is to get some experience. So let's get some XP. I'm going to start off with a command that's going to install it for you. You can just use apt-get install git, and this will search your package repository and it will install Git. That is if you're on a Debian-based system. If you're on a Red Hat-based system, that command is yum install Git. If you're on a Mac, that is brew install Git. And if you're on Windows, you can go to git-scm.com and you can download Git and follow the graphical finicky wizard thing that goes and installs Git. Once it is installed in your system, it should be available in your command line path. You should be able to use git --version, if I can spell it right, and it'll output a version for you. Now, what I like to do is I like to make a directory that will contain the repositories and the stuff that I'm doing, because I like to be organized. I don't want stuff just sitting right there nilly-willy in my home directory. So I'll create a directory called Git. Sometimes I'll call it work, who knows. And in this instance, I can initialize a new repository using git init. I'm going to call it sample. And what this will do is it will create a directory called sample. Inside of that directory, ls-la sample, you can see there is a .git directory. This is like the raw repository that contains all of the data. Now, quick note about this stuff, this just talks about the initial branch name, and if you want this to go away, you can use git config, just like it says git config global init default branch, and you can specify what that is. So I'll just paste that there, and I'll say default branch, we'll call it main. Simple enough. Go into the sample directory, and just to show that makes it go away, we can git init another and just create another Git repository, and you can see that actually makes it go away. We're going to make that go away for now. We're going to go into sample and start all over again. I can just list the directory under Git and kind of sort of explain some of these things. For example, this config file, this contains meta information about the repository itself. This description is just what it says, description. You can put stuff inside of hooks, and if it matches one of the names of the hooks, like without the sample, you can look that up later and figure out how to hook into various operations within Git. So like as you commit, you can have pre-commit, you can have pre-push, you can have pre-pull down. Like there's all kinds of things you can do in Git that extend its capabilities and such. The rest of these are just like raw information about the Git repository itself, and I do not recommend tinkering with the inners of this. Pretty much the only thing you really want to know about is the config file and the hooks directory, but more on that later in the advanced stuff. So we'll start with a new file. We'll call it readme.md. MD is just for Markdown and pretty much used for basic documentation, stuff like that. I'm going to install my favorite editor, Nano. I know there's going to be a lot of people in the comments when I say this. Nano is the superior text editor over Vim or Emacs or whatever the butterfly does to change the magnetic waves and sparkles the hard drive to do. There's an XKCD comment, a joke I'm making right here. So we'll just say hello world documentation. And I'll create git status will output the status of your current repository. Also, there's a thing that I can, there are various colors that you can set that make Git more, how do I say, like user-friendly. So, if you remember that git config global command that we ran, that's actually in your home directory. And if we were to edit that file, you'll see default branch is main. You can also paste in some configuration. I will leave this in the description below. If not the actual text, it'll be a link to a gist. Now, what this does is it makes status a little bit more, I would say, intuitive. So if a file is not tracked yet and not in Git version control, then it'll come up as cyan if you have it configured as I've done here. Git status shows you the status of your current repository. You can stage or add. Git stage and git add are the same command. I don't know why they did that, but if I do a git status after I do a git stage, you'll notice the color has changed and it's gone from untracked to now changes to be committed. And Git is basically a file tracker. It doesn't necessarily have to be code, but plain text files definitely do work better with Git than binary files like Excel documents and stuff like that. The reason being is because Git allows you to see the differences between what changed. And what Git is actually doing is it's stashing the state of the file as it is. So every time you do a commit, and we'll do one now, and say git commit, we'll say -m to give it a message. Every commit is annotated with a message. So by adding a message saying adding readme, just have some kind of note that says, hey, we're going to add this file. You're basically taking the state of the readme and you're creating a checkpoint. And Git is like, okay, scanned, got it. I'm going to take a copy of this. I'm going to create a checksum out of this change. And this is atomic, meaning this change will forever be remembered in this repository. And if I were to copy this repository elsewhere, or if somebody else was to clone the repository, they would be able to see this file in its original state and every change that is made therein after. And you'll notice here, Git is complaining about the username and the email address. It was automatically picked up based on what we could tell from your environment. But if you don't want me to complain about this every single time, you can change that by telling me what your username and what your email should be. So username, I could change it to Marcusano Draconis. Hey, that's me. And then I can say user.email to me@me.com. That's just an example. Doesn't have to be a real thing. You can put whatever you want in there. It's really just an identifier so that Git knows who to call you and what to call you. The config function allows you to set config, and the global operator, the config function sets the configuration for it. The global operator says, I want this to be set in the home directory. And so here we can see user, email, all that's been set. Now, if I did that first, this would have showed up at the top, and it'd be a little bit easier to see it because it would have been first. But and Git kind of sort of writes to this file as you write the configuration and put it to it. So now that we've made a commit, say you want to see the history, say you want to go back in time, you can use git log, and that will output the changes that have been committed to this repository since inception. Now, there are additional switches, operators, configurations, and such you can add to this as well, so that you can curate the log. You can format the log. You can say, I only want to go back to this commit. I want to look and inspect the details of this commit, and gives you more details about what happened in the history. Now, once you have a repository, you've made commits and such, and you want to be able to push it to a remote, That remote doesn't have to be remote. That remote can be local, and I'm going to show you how you can do that too. You can go to GitHub, and I'm going to introduce that next. But first, I want to show you something. You can git init --bear, and you can say sample remote. Now, what that's done is that's created another GitHub repository that is a remote that Git can push to. And you'll notice the contents of this directory look a lot like that .git directory that we looked at before. Same rules apply. The hooks directory on the server side can be triggered in order to effectively do stuff on behalf of receiving changes, pushing changes out. There's no branch to be checked out, so there's no commit hooks to be had here. But it's just good to know, because when I get into teaching you how to create your own Git server so you don't have to rely on GitLab, GitHub, Git, whatever UI interface, you can roll your own. This will be key here, because then you can have fun creating your own little operations and DevOpsy stuff inside of that as well. So now that we've made a commit, now that we have given it some logs in that commit, we can add a remote. So we can git remote add origin, and I could specify the path to the remote. Now if I git push, I can push my changes. Oh wait, I have to set the upstream. So you can set the upstream. And this configures Git to say, all right, I'm tracking this local branch. I'm going to push my changes up to the remote branch. And in the process of doing that, I'll be able to automatically line my local branch up to the remote branch. And that way I can just push and make changes going forward. So let's make another change. I'll illustrate that now. So hello world documentation. This is an additional change. Save changes, and we'll quit the file. Now, I've made a change. You can do a git status, and we can see that it is now green. More than that, it could say changes not staged for commit. So you notice it's not untracked, but it's also not staged. This is another thing that says there's a change that's waiting and ready, and this file has been modified. And if you want to see what's changed, you can use git diff, and the diff will tell you what has been added, what has been subtracted, and what are the changes. There's other tools and utilities that give you a different kind of diff. This is what they would call a unified diff, which means you see it all in one vertical and you're not seeing two split side-by-side changes. Some people have an easier time seeing the side-by-side diff as opposed to the unified diff. Personally, I was raised on the unified diff, and so I'm quite content with this as well. So we do a git commit, and we'll give it a message, and we'll say improve the README by providing additional information. Oh, we forgot to add the file. So you can either commit the file directly by providing them on the command line, or you can stage or add the changes before you commit, and that will enable you to make a change as well. This is probably the part where people look at this going, oh my god, there's like 9,000 ways to do the same thing for the same operation. Yes, it is, I know, and that's what happens when a lot of people get involved in something. Everybody just has their way that they want things to get done, and Linus, I'm sure, was just like, okay, fine, we'll just do this. All that screaming and stuff probably got to him at some point. I notice he has calmed down quite a bit since his younger days. So if we do a git status again, you'll now see a difference. We're on branch master, and it is ahead of the origin by one commit. You can use git push to publish your local changes. So when I do a git push, it pushes to that remote that we just created, that directory that is just sitting next door. This is really cool because it allows you to do things with Git, and you can store them locally. And one of the best practices that I always recommend is whenever you're starting with a new code project, just initialize a repository, put your stuff in there, and you can commit locally. You don't have to have a remote. There's a lot of people that are writing code without a Git repository, and that, to me, that just makes me feel like you're writing code naked, like no pants. You're just totally out there, wide out in the open, and like, what happens if you want to go back, if you want to reference a change that you made before, if something happened in your history and you want to be able to take a look at that and go back into the past, you can't if you don't have a repository. Mercurial, Subversion, CVS, doesn't matter, but just something, please. Have some kind of version control so that you can go back and see what previous versions are. It's kind of sort of like a time machine. You take a checkpoint, you make a commit, and I will make frequent commits locally before pushing up to the remote, because oftentimes I'm making a lot of changes, and sometimes I want to annotate my stuff differently locally before I push it back up. I try to avoid as much force pushing as possible. Those are just some best practices kind of things. But now that we've pushed our change up, we'll do a git status again. And you can see we're now up to date with the master, nothing to commit, working tree is clean. And so now you understand how to install Git, you understand how to commit, you can see the differences and what changed in the file, you can track the changes in the logs and see what goes back in the history. And these are like the very basic fundamentals of Git. I just wanted to share this much with you. In our next video, we'll pick up from here and we'll go into stuff like merges. What happens when you have more than one person working on the same project?